factor some quadratic trinomials. This is based on our last section, 11.5, and we know that we are sort of unfoiling. So we know that whatever terms we put in the front are going to multiply to give us x squared. That has to be x and x. And the numbers in the back are going to multiply to give me negative 18. So that means 18 and 1, 9 and 2, 6 and 3 are our possibilities. And since it's a negative 18, that means we're going to have one positive and one negative. And when we combine our outside and our inside terms, we're going to get a negative 7x. So the combinations that will get us a negative 7x, that's going to be a 9 and a 2. And since we want a negative 7, we'll make the 9 negative and the 2 positive. Our outside terms, when we multiply, would give us 2x. And our inside terms would give us negative 9x. Those combine to give us that negative 7x in the middle that we needed. So there's our factored version. A challenge problem. What happens when we have something in front of our y squared term in this case? So, well, we're going to start like we always do. In order to get 2y squared, now it's not y and y, it has to be a 2y times a y. In this case, it's pretty simple because the only way to get 1 is 1 and 1. Everything's positive. So let's verify that that's what we end up with. We'll do the whole FOIL here. First, outside, inside, and last. My first term's 2y squared. My outside is 2y. My inside, 1 more y. For my last term, set it up to work that way. That's going to give me 1. I get 3y in the middle. So that's my answer. In today's lesson, we're going to be factoring trinomials like we've been doing, but this one's a little more complicated because now we have an a term in front of my x squared term. So that isn't a 1 anymore, which will complicate things a little bit. So let's get started. In this case, I have a 5v squared in the front. So the only way to get 5v is 5 times 1. In the back, I have a 2 and a 1. So let's open up our binomial parentheses, and that has to be 5 times v in the front and v. The question becomes, how am I going to get 2 in the back? Well, it has to be 2 and 1, but I'm going to combine to get me 11. Well, there's a couple possibilities. Could be plus 1 and plus 2, or it could be 5v plus 2 and v plus 1. The question is, which of these possibilities is going to get me 11 in the middle? Well, we want to multiply the 5 times the 2 because that gets us kind of close to 11. So in which case am I multiplying the 5 times the 2? That's this first case. My outside is 5v times 2 is 10v, and my inside terms is 1v. Those combine to get me my 11v. So there's a little bit of guess and check involved in these. But if you're strategic about it, you can choose choices that don't waste your time. Let's look at another example. We have 3 in the front, so the only way to get 3a squared is going to be 3a and a. In the back, we have 5 and 1. Everything's positive, so we don't have to worry about any subtraction. So we have 3a and a. How am I going to get 16? Well, if I multiply my 3 times my 5, that gets me pretty close. So where does the 5 need to be? Well, to multiply with the 3, that means the 5 needs to be in the back. That means my 1 is in the other space. And to convince ourselves, let's take a look at our outside and our inside terms. Our outside gives me 15a. My inside terms gives me 1a. Those combine to give me my 16a, which is what I needed. So that's my answer. Let's look at another. 2x and x, 7 and 1. A little complicated though because we have a negative 7. So that means we're going to have one positive term and one negative term in the back. 2x and x. So I have to decide where the 7 and the 1 goes and which one's positive and which one's negative. Well, if I'm trying to get to negative 13, which combinations get me close? 2 times 7 gets me close. 2 times 7 is 14. So let's put the 7 where I multiplied with the 2. Then the 1 has to go in the other location. Since one has to be positive and one has to be negative, we have to decide which one's positive. Since I want a negative 13, let's make the 7 negative and the 1, excuse me, the 1 positive. Just to verify, 2x times negative 7 is negative 14x plus 1x. Those combine to get me my negative 13x, which I needed. So that means that is my answer. Let's look at a little more complicated example where they're both not prime. In order to get 2k, well, that's 2 and 1. But 6 could be 6 and 1 or 2 and 3. Now we have more possibilities to consider. Everything's positive in this case. 2k and k have to be in front. We're trying to get 13. So let's look at what combinations get me close to 13. Looking at the possible multiplications, I see if I multiply my 2 times my 6, that gets me 12. That's pretty close. So I'm probably going to be using those two. Let's put the 6 in the back, the 1 here. Everything's positive. And to verify, my outside is 12k. My inside is 1k. There I have 13k, which I needed. So that's correct. Let's look at another. We have 5x and x. So 5 and 1 are the only ways to get that. And then I have 4 and 1 or 2 and 2 as possibilities to get my 4. Further complicated by the fact that that's a negative. So I'm going to have 1 positive and 1 negative. All right, so let's set it up. 5x and x up front. I want a positive 19 in the middle. So I'm trying to build a positive 19. What numbers can I multiply that are going to get me close to that? Well, 5 times 4 gets me close. So I'm thinking I'm probably going to use that one. Let's put the 4 in the back. 5 times, well, let's put my 1 here. One has to be positive and one has to be negative, and since I want my middle term to be a positive 19, let's make the 4 positive because it's going to be multiplied by the 5. Let's make the 1 negative. 5 times 4 is 20x, negative 1x. Those give me my 19x, so I'm good. Here's another. Here I don't have a prime number in the front. That could be 8y and y, or it could be 4y and 2y. In the back I do have a prime number, so it's 3 and 1. So everything's positive, so I'm not doing any subtracting. I want to get to 11 in the middle, so let's figure out which combinations will get me close to 11. I'm looking at 8 and 1 and 3 and 1, because I know 8 times 1 plus 3 times 1 will get me to 11. Outside gets me 8x, my inside gets me 3x, and those combine to give me 11x. So that is correct. Don't worry if you're guessing and checking a little bit and trying different combinations. When you're first learning how to do these, there's just going to be some of those cases. Other examples. This one's a little bit more complicated because my a term in front of the x squared, that's not a prime number, so that could be 6x and x, or it could be 2x and 3x. And in the back, I have a 5 and a 1, but we have a negative sign, so that means one's positive and one's negative. We're trying to build a 7x in the middle. So let's get started here. What combinations are going to get me close to 7? Since I'll be subtracting, I'm thinking probably 2 and 3 and the 5 and the 1, because I can go 2x and 3x, and if I multiply the 2 times the 5, and that gets me 10, and the 1 times the 3, that gets me 3. And so if I have a positive 10 and a negative 3, when I multiply these here, I have my outside gets me 10x, my inside gets me negative 3x. Those two are going to combine for my 7x in the middle. So there we go. Another example, a little bit more complicated again. Now I have a 4p and a p, or a 2p and 2p. And in the back, multiple possibilities, 6 times 1 or 2 times 3. One has to be positive and one has to be negative, and we're trying to build a negative 5 in the middle. So let's see, how can I get close to a negative 5? Looking at combinations of these guys times those guys, and then a difference. How about a 4 times 2 gets me 8, and 1 times 3 gets me 3. 8 minus 3 gets me negative 5. So 4p and p. I want negative. 4 times 2 is 8. Negative 8 and a positive 3. So my outside terms give me negative 8p. My inside terms give me positive 3p. Those would combine to get me negative 5p, which is what I needed. So there's my answer. And then finally, the most complicated one of the day, looking at this monster, we have a lot of possibilities for 12 in the front and a few possibilities for 8 in the back. But one thing that you need to consider on all of these problems is there a monomial that can be factored out at the very beginning? Because if we can simplify our coefficients, then that's going to simplify all the possibilities that we have to consider. I'm looking at 12, 46, and 8. I know they're all even, so I can factor a 2 out. So this becomes 6a squared minus 23a minus 4. And now I'm just trying to unfoil this quadratic trinomial here. Okay, so that means the front term can be 6a and a, or it can be 2a and 3a. And in the back, I'm looking at 4 and 1, or 2 and 2. And since I have a negative sign there, that means one's going to be positive and one's going to be negative. And the middle term that I'm trying to build there is a negative 23. So let's get started. All right, how am I going to get close to negative 23? Well, immediately I see 6 times 4 as getting me really close. So let's try those guys. Let's go 6a, and it needs to be a 1. So let me get my eraser. That's 6a and a. And in the back, 4 and 1, I want to get close to 23, so let's put the 4 where it will be multiplied with the 6, and the 1 in the other spot. One's positive and one's negative. Since I want a negative 23, let's make the 4 negative and the 1 positive. And just to verify that I have the right combination, my outside terms get me negative 24a, and my inside terms give me 1a. Those are going to combine to negative 23a. So my final answer, I have this 2 here that I factored out, and then I've unfoiled my quadratic trinomial in parentheses. So finally I have 2 times 6a plus 1 times a minus 4. And that's it for today.